Our next lesson is describing motion. Again, we're continuing on in our learning target of I will explore how motion diagrams and particle models can represent motion, collect scientific observations, and utilize these observations to draw conclusions. So basically, we're doing the first part. We're going to explore how motion diagrams and particle models can represent motion. Okay? So motion happens all around us, right? I mean, every little thing that we do is motion, right? If we raise our hand, it's motion. If we walk across the floor, it's motion. If we speak, our mouth is moving, right? So you can see it in the picture. Fast trains, speedy skiers, sorry, slow breezes, lazy clouds, right? All those things are moving. Objects move in many different ways. They can move straight ahead or backwards. They can move fast or slow. Um, they can move in 1, 2, or even 3 dimensions. They can move in circles or spirals. So how do we describe motion of an object in motion? Okay, so when an object is in motion, its position changes. So if you're looking at this picture, it's the same person. It's just multiple pictures placed one on top of the other. And you can tell that this person is moving because um, her distance is changing. Okay. Okay. So since it's always easiest to understand when we start with something simple, that means that we are going to start out with just looking at one-dimensional motion. Okay. Like in this picture, right? One-dimensional motion is you're either moving straight ahead or something like where you're moving on the ground, let's say. Okay. Or you're moving straight up or straight down. Okay. Um, in this case, you're only interacting with one plane. So if we think of it in math terms, okay, but it's in a straight line. Okay, you're not zigzagging or any of that kind of stuff. So describe motion, we must first draw a coordinate system. Okay, a coordinate system is used to describe motion that gives the location of the 0 point of the variable and the direction in which the variable or variables increase or decrease. So for example, here's a coordinate system. It's basically just a number line. It's in the x axis, x plane. Okay. Our origin is the 0, right? And if we move, we can move in the negative direction or backwards, or we could move forward, right? In the positive direction. Okay. So the origin is the point in the coordinate system where all of the variables have the value 0, right? So at this point right here, any variables you're working with start at 0. Time is 0, distance is 0. That's like, this is where I'm starting from. Okay. The arrows that are drawn to show what direction something is going are called vectors. Okay. So vectors are arrows that show direction of motion. Okay. Once you've gotten the coordinate system down, we can draw a series of images, right, spaced at even intervals of time. Okay. So in our picture here, each dot is 1 second apart or 1 minute apart, possibly. Okay. So the position of the object is marked at the same interval of time. Okay, this is called a motion diagram. Okay, in a motion diagram, each picture represents 1 second of motion. At least in physics it does. So the blue dots represent the object's position at the end of each time interval, right? At the end of each 1 second. But this diagram is also a motion diagram, right? Even though the distances aren't the same, the time is still the same, right? So the other thing that can happen is that if it's moving really fast, is the motion could be blurry, right? Like the train in that second slide that we were looking at. If the object size is much less than the distance that it moves, we can replace the person with a dot. Okay, so instead of having the person or the object drawn as what it is, if it's much less than the distance that it's traveling, you can replace it with a dot. Okay, so the dot represents the center of the object, right? So this one looks like it's underneath this guy, but really it should be, like around his tummy. Okay. When the diagram becomes then the diagram becomes easier to read. This is called the particle model of motion. Okay, so this is a motion diagram. The dots are the particle motion, the particle model of motion. Okay, so to sum it up, motion happens everywhere. When an object is in motion, its position is changing. And then describing the motion can be done using motion diagrams or the particle model.